Alrighty, welcome everybody. Today we'll be going over the Linux shells room, SAL1's certificates. So let's go ahead and start out. So Linux shells, it's an easy room, supposed to be 45 minutes. We're going to learn all about scripting and the different types of Linux shells. So an introduction to Linux shells. As regular users of operating systems, we all extensively use the GUI or the graphical user interface to carry out most operations. It takes a few clicks on different options and your task is done. However, you can perform almost every task by writing commands in the CLI of your operating system rather than using the GUI. The shells give you some great features for the commands that you write in your CLI. So it's this way of interacting with the OS ends up being much more efficient and resource friendly. So yeah, hosting an OS without a whole GUI side, if you can get it to only be CLI enabled, great. It's much lighter. You don't have to invest nearly as much in hardware to be running that, and it can be way more efficient, especially if you're trying to do commands at scale. So let's keep on going. Suppose you are a restaurant and you have two options for your food. So suppose you are in a restaurant and you have two options for food. The first option is to order food from the menu and the waiter will serve it. And the second option is for you to cook your desired dish in the kitchen yourself. In terms of a Linux system, the kitchen here is the OS and it's using the GUI of the OS and it's just like ordering food from the menu. The waiter will then serve it to you. However, using the CLI means you have to go to the kitchen, so the operating system yourself, and cook your desired food. In this example, Shell would help you cook your desired dish by giving you some recipe suggestions. So that's great. So we're talking about, the waiter in that instance. While using CLI to perform operation, and the system will give you more power control while carrying out the task because you're doing it yourself. All right. So it's an all right example. Essentially it's saying the GUI is the middleman. All right, so the GUI might not give you all the power and control to do exactly what you want. That may be you being in the kitchen using the CLI where that would enable you to. So there's pros and cons to each. We're learning about the CLI though, so we're going to be going into shells. The third paragraph here says you might have seen hacking scenes in movies that show cool terminals with the main commands getting executed. This is because most Linux users prefer to perform operations by using ring commands on the CLI using shells instead of the GUI. This room will teach us how to interact with the Linux shell. We'll also explore different shells available in Linux and write some shell scripts at the end. So, sounds like a pretty fun room. We're going to go over several different um, Linux shell is available, so not just Bash. Even though Bash is typically the default one that everyone knows about, there are alternatives to that. And we will be writing some shell scripts. We're going to be analyzing some scripting commands and everything and be able to edit our own. So that's pretty exciting. I hope you guys are kind of hyped up for that too. But go ahead and start up your machines if you haven't already, which will load up instead of our regular Ubuntu GUI, it brings us into that. So we have a question here though is who's a facilitator between the user and the OS? Going off of what we've learned so far, that's going to be the shell, all right? So we know that that's a facilitator, so let's learn how to interact with the shell. So you want to start up your machine, it'll load this up. We have credentials here. That's if you are trying to hop on your own VPN connection. If you do the attack box, it's already there for you. So once the machine opens in the split view, you have the shell prompt ready to accept commands. So we can see that at our user and our box, and it has the little tilde $sign. All right. So most Linux distributions use Bash, which stands for Born Again Shell, as their default shell. However, the default shell displayed when you open the terminal depends on your Linux distribution. So different flavors, distros of Linux might have a different default. It might be uh, like Z Shell. Just there's alternatives. All right, different products will have whatever they want set as. Majority of them are going to be Bash though. All right. So you have already explored the basic Linux commands in the Linux fundamental module. So we're just going to go over the most important ones So you guys should already know these, but remember we have print working directory, which is PWD. That shows you where you currently are. So we're currently in the home/user directory. We have CD, which then allows us to change directories. So in this instance, they use it CD space desktop to change into the desktop um, directory. So let's see if we have that. No. So we can do ls, because it turns out in this instance over here, we use ls, which is list contents, and we have a flag_hunt dot sh file in here. And when we look over here in the example, they did that in their directory where they're at, and they have desktop documents, downloads, music. So they're just in a different place for this example. So we're going to follow the example, see what it's saying, and if you want to go ahead and follow along in your own terminal over here, go right ahead. All right. Then they're doing cat, where you can read the contents of a file. So in file name.txt, we have this as a sample file, followed by this is the second line of the sample file, or the second line of the file. And then finally, they go over grep, which is the search command. So here they have grep. They're searching for thm in the dictionary.txt file, and they did return with a line that says the flag is thm. So we've already gone over these before. We're not going to spend a lot of time on them. So I feel confident you guys can use these 5 common functions or 5 common commands, as well as answer these questions. So what is the default shell in most Linux distributions? I think we said about 15 times now, and that's going to be bash. All right. Now, which command utility is used to list down the contents of a directory? So they kind of gave us a hint in here with the list. So if we're looking at the 5 of them, print working directory, change directory, list directory, display file contents with cat, or searching with grep, it's going to be ls, all right? Just like how we used it over here to see this flag_hunt. Next, what command utility can help you search using anything in a file? So scrolling up, these are our options, and it's going to be grep. Alrighty, moving on to task 3. All right, we're now going to talk about types of Linux shells. So like the command prompt in PowerShell and Windows OS, Linux has different types of shells available, each with its own features and characteristics. So multiple shells are installed in different Linux distros. To see what shell you're currently using, type in the following command, which is echo, then $shell, and it will say what you're currently using, which in this case we're using bash. So it will say bin/bash. All right. For the rest of this, we will be following along with the examples simply because in this virtual machine, it doesn't have all these other ones installed. So you can use this command, which is cat space etc shells. So the etc shells file contains all the installed shells on your Linux system. All right. So they went into that, and as you can see, we have bash here, we have rbash, we got the Z shell. I'm pretty sure I'm pronouncing that incorrectly, but anyway, the Z shell one. All right. And then it will say, hey, you can switch in between them by inputting the name of it. So in here they do ZSH, and that will switch them from bash over into Z shell. All right. Hey, okay, good. It is Z shell. Okay. So you can, if you're in bash, you can tell it to go to Z shell. If you're in Z shell, you can tell it to go to bash and whatnot, just depending what you're comfortable with and what you're really trying to attain. All right. And then it does give you a little bit of assistance, because it will tell us how to mark whatever the shell change that you want it to be as the default, so you don't have to keep doing that every instance that you open it up. And how you do that is with this command. So it's change shell, so chsh and tac it s, and then you identify which one that you want. So you could do user bin z shell, or user bin bash, or user bin fish. It just depends, whatever one that you want, whatever one that you actually want to install. So that's going over how to see what's available, how to switch, how to permanently establish that. Then we're going to go into three different types of shells for Linux. So we know Bash, we don't know Fish yet, we don't know Z shell, but it's going to give a good comparison of what pros, cons, and everything else like that. So we're just going to read this really quick. So Bash is a default shell for most Linux distros. When you can open up the terminal, Bash is present for you to enter your commands. Before Bash, some shells like SH or KSH or CSH had different capabilities. That's before my time, even. All right. Bash came as an enhanced replacement for these shells, borrowing capabilities from all of them. So this means that as many of the features of these old shells and some of its own unique abilities, some of the key features provided by Bash are it's widely used. Um, it's a widely used shell with scripting capabilities, so you can script in Bash. Sweet. It offers tab completion, which if we look at like for this example, so if I put in a command of cat and if I start typing out flag underscore hunt dot sh, I can put in FL and then I can hit tab and it will complete that. So it will use its own logic to say, okay, this is exactly kind of what you want, especially for long file names. If there are multiple instances of, for this example, files that are starting with the characters FL, then I could hit tab again and it will cycle through them. So it tries its best. It's not 100% perfect because you might have a whole bunch of files in a directory and in your head you're thinking you're going to get one and it might display one before it. All right. So still pay attention. I think it saves a lot of time as you get more comfortable navigating in these environments. You'll find yourself using tab a lot more just to complete stuff. All right. And finally, uh, Bash also keeps a history file. So you can see the history file by typing in history, and it will tell you all the commands that you have done. So in this instance, we've done print working directory. We tried to change the directory to desktop. Then we listed the contents. We did the echo shell and history itself. And this is reading the same thing through if you hit the up and down keys on your keyboard. So if I hit up, it'll say history. Next, it'll say echo, ls, cd, pwd, and then I can scroll through that doing up, down, and stuff like that. So if you're using similar commands, you don't have to type them all out all again and again and again. You can pull up, hey, I use this one. Maybe I just need to add in a switch onto the end of it. So history is a cool feature. Um, it's kind of expected in most of them now, but hey, Bash has it, and we're highlighting that does. Next, we're going to talk about Fish, which is a friendly interactive shell. And it's not the default in most Linux distributions. As its name suggests, it focuses more on user friendliness than other shells. So some of the key features are it offers very simple syntax, which is beginner friendly. Unlike Bash, it has auto spell correction for the commands you write. In Bash, hey, you type this out, that is what it's going to go with. All right. So Fish has spell check, which is sweet. You can customize the command prompt with cool themes using Fish. There's a syntax highlighter. That way, kind of like when you're using PowerShell, where your command and the object and then things in quotes and everything is highlighted in a uh, different color. That makes it easier as you're scripting and everything. Just that it's a common feature in most IDEs for programmers. Like color coding syntax is great, and Fish has that. So it would be cool if Bash had it, but it don't. And finally, Fish also provides scripting, tab completion, and command history functionalities, just like Bash does. All right. Finally, we're going to talk about Z shell. So it's also non-installed by default. It's considered a modern shell that combines the functionality of some previous shells. Some key features are a Z shell provides advanced tab completion and it's capable of writing scripts. Cool. Just like Fish, it has spell correction for commands. It offers extensive customization that may make it slower than other shells and also provides tab completion, command history functionality, and several other features. So when you read into the alternatives, Bash suddenly isn't as awesome as it seems, but it is just the default because everything that Bash does, modern alternatives will typically have all those features and they'll build upon it to make your life easier. So here's a table that's going over Bash, Fish, and Z Shell. Um, it's kind of summarizing what we just went over, so I'm not going to read this. We will in it though with saying selecting the best Linux shell depends on your usage and its features. The shells discussed in this task are some of the many different shells available in Linux. You can compare the features of these different shells and choose which one is best based on your task. So if you have, cool Linux box and you're running Kali or whatever on it, you can step out of the mold, make your tools work best for you. You don't have to do bash just because it's a default and it's widely accepted does not mean you have to operate out of that. All right. Choose whatever works best for you. All right. So we have 3 questions here. So first one is what shell comes with syntax highlighting as an out of the box feature? All right. So out of bash, fish, and Z shell, out of the box, it is going to be fish. Bash can't do it, and Z Shell, if you add in some plugins, then it can do that. But out of the box, it's going to be fish. All right. Next, what shell does not have an auto spell correction? The modern day ones do have it. Bash, unfortunately, it's still modern, but it just don't have that feature. So, put Bash. And finally, which command displays all the history previously executed commands of the current session? Sorry, I just gave it away. Um, reading it, I'm like, oh, that's not even what it said, but it is history, all right? And we use that in the example to see what our previous commands were for the session. All right, so we are about to start task 4. So we're about to get into the good meat and potatoes of this. So we're going to talk about shell scripting and components, all right? So a shell script is nothing but a set of commands. Suppose a repetitive task requires you to enter multiple commands using a shell. Instead of entering them one after one on every repetition of that task, which will take more of your time, you can combine them all into a script. Then to execute all those commands, you only execute the script, and the commands will be executed as they go down. All right. So all the shells mentioned in the previous tasks have scripting capabilities. Scripting helps us to automate tasks. Before learning how to write a script, though, we need to know that even though Linux shells have scripting capabilities, this does not mean that this does not mean that you can only make a script using a shell. So what that's saying is Bash, Z shell, Fish, they will like you can script in them, but you can also use other programs to actually, write out your scripts, IDs, things like that. In this example, we are going to be using Nano, which is a text editor. All right. So going back to it though, scripting can be done in various programming languages as well, so you're not stuck scripting like in bash commands. You can, Python and all these other ones. All right, whatever is the best tool to accomplish whatever you need to. All right. Um, so it's not going to go into different programming languages. That's not in the scope of this room. There's going to be other rooms about that. But the first step is open up the terminal and select a shell. Let's go with the bash shell. So that's already the default. You're already there. Unlike the other commands we type in the shell, we first need to create a file using a text editor. So to do that, we'll type in nano. We're going to name our shell script. So we're going to put it as first script. And importantly, it needs to be in the extension of sh. All right, so you can type out a script as a txt, but then if you try to run it and stuff, it won't run because it has all the commands in there, but it's the wrong extension. So it's not going to run it as a script. You need to do .sh. All right. So when we do that, now it opens up Nano over here, and we're greeted with a big old blank screen, but at the top, it will give us our file name up here, and it will say the version of Nano that we're on. The first thing we are going to do, because it is a script, is we're going to start with the shebang. Pretty much all that shebang is it's telling whatever is going to run the script what to interpret it with. So the shebang technically is this part. So it starts with # exclamation point. Then you're going to do /bin /bash. All right. And now we're telling it to run as bash. All right. And nearly every shell script that you'll see, it should start off with something saying what to interpret it as. So If we go ahead and save this right now, nothing's going to happen because we haven't told it to do anything. Through the next examples, we're going to learn how to do some programming basics. So I'm going to go ahead and save my first script over here. To do that, it's Command X, and then it'll say, hey, do you want to save it? There's been changes. You hit Y for yes, and it should bring you back. So down here, I can see I am now in my regular portion of the CLI because we are going to just be reading off of the examples. So the first thing we do, we're going to learn about variables. So a variable stores a value inside of it. Suppose you need some complex values like a URL, file path, and name maybe. You need it several times throughout your script. Instead of for memorizing and writing them down repeatedly over and over, you can store them in a variable and then just use that variable name whenever you need it. So the script below just displays a string on the screen of what's your name. This is done with the echo command. So they have an echo command. Then it's going to display, hey, what's your name? Then when we want to take input from somebody, we use a read. And then we are defining our variable here. So whatever they input as the answer to, hey, what's your name? We're going to save that value as the variable of name. Now, we're able to later in this script call back their name, which we do in the next line, but it also allows us to run the same script for multiple people, and they can put in their own names or different names or whatever as their names, and it's not going to be conflicting with the other ones because for this one session in which it's running, it's just asking for, hey, what was the variable of name actually defined as here? So for the third line, we say echo, so it will display welcome. In order to call a variable, we use a $sign. All right, so $sign, the variable name. So we have the variable name. We'll do $sign name. You can put $sign name, $sign name, $sign name, $sign name, and it will just regurgitate, this 4 times what their name is. All right. And then, so that's what variables are. In order to make a script actually executable, you need to, at least in Linux, give that file proper permissions to execute. So how they do that is you do chmod, so that's going into the permissions. Then you are going to say +x, and that is going to then define whatever file that you identify as a file that is allowed to be executed on your workstation. So chmod space +x space file name. All right. So now that the script has the execution permissions, it's going to tell us how to run it and how you run it. If you're in the directory, in the same directory as it, you would do period / and then the name of the script. So we can do that over here. So if I do period / and we're going to go with flag hunt. I don't know what this does just yet. Okay, but it ran it. So, and it echoed back some stuff, and we'll be editing this later in this room. So for right now, we can at least see it runs and it's saying, hey, flag search in the directory blank is in progress. Then it's doing grep and it's trying to find, looks like files with the extension of log, and it didn't find it in whatever directory. All right. So we've learned what variables are, we've learned how they operate, we've learned how to make a shell script executable, we've learned how to run a script as well. All right. Now, if you don't put the // in it, then it's going to search everywhere except for your current directory for it, as it will interpret it as you're searching for the script in the path environment. All right. Typically, that's going to generate an error. So it even says, hey, the shell will search for the script in the path environment variable, and it will not find the defined script in any of those directories and generate an error. All right, so typically, if you are calling up a script or whatever it may be, you want to be precise in where is going to come from. You can drill down, like you don't have to be in the particular directory and do, period forward slash to get it. You can still be in a different directory and just identify where that directory is. So, forward slash home, forward slash user, blah, 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 blah. Drill down. Maybe it's in their documents, maybe it's in their downloads, and then just call it from there. And that's all right. Okay. So next we're going to talk about loops. So loops is how you get iterative results, or keep going on and on and on in scripting. So how do they define this? So loop, as the name suggests, is something that is repeating. For example, if you have a list of me and friends, you want to send them the same message. Instead of sending them individually, you can make a loop in your script and then give your friends list to the loop in the message, and the loop will go down each one of the entries in the list that you gave them and send them that same message. So for their general explanation loops, they're writing a loop that's going to display numbers 1 through 10 on the screen. So if we look over here, they have a comment, define the interpreter. They have the shebang there. So we know we're operating in bash. I'm just going to read this how they explain it so I don't confuse anybody by jumping ahead. But so the first line has a variable of I, and that will iterate from 1 through 10, and it will execute the code below every time. Do indicates the start of the loop code, and done indicates the end of it. In between them, we have the code that we want to execute in the loop that is to be written. So this loop will take each number in brackets and assign it to the variable of I for each iteration of it. And then this line of echo $I will display the value in each iteration. So they go ahead and they execute this. It's called loop script. They're in the same directory. So period forward slash loop script.sh. It'll start with 1 because that's what it was defined as. Next time it's going to do 2, and it's going to do 3, and it's going to go all the way down to 10. It won't hit 11 because they defined it as 10. All right, so 10's the stopping point. So going 1 through 10 didn't start at 0. 1 through 10 going through bam, 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 bam. Loops are very useful. There's a couple tricks with them. This is not a programming course, but for simplicity's sake, remember that loops start with do and they end with done, and in the middle of it is what is actually being executed over and over and over. All right. Next, we'll talk about conditional statements. And conditional statements are an essential part of scripting. They will help you execute a specific code only when the condition is satisfied. Otherwise, you can execute another code. So suppose you want to make a script that shows the user a secret. However, you want it to only be shown to some users, specifically high authority users. So you want to make a conditional statement that will ask the user their name. Then if that name matches the high authority user's name, it will display the secret. So let's go ahead and look at this script right here. So let's define the interpreter, shebang. So we're using bash. Echo, please enter your first name. Cool. Then it's asking for input using read. It's allowing the variable, it's establishing the variable of name. So the person will put in a value into name. And if the name is equal to Stuart with a capital S, then display this echo code of welcome Stuart. Here is the secret, THM_script. Else, if it's any other value that they put in the name other than Stuart, if they put in Stewie, anything like that, then it will display this one, which is sorry, you are not authorized to access this secret. And then you end it with FI to end that loop. So in this conditional statement, you can start a conditional statement with if, then you want to define. So if this equals whatever, you're going to have a then portion of it. You're going to define what, if it's true, essentially, then do this. Else is the false portion of it. So you need to define that as well. And then you close it out with FI. Not expecting you to remember every single thing about this, just know that that is what's going on and be able to recognize if you see this in scripting, okay, it's an if then statement essentially. So it's conditional statements. Don't think it's going to run through here and then run immediately through there. as it needs to do one or the other. All right. And we can see here in this example, the person did put their name as Stuart and they got welcome Stuart. Here's a flag. And then they put their name as Alex and they got the other one of sorry, you're not authorized. Access is secret. Finally, we are going to go over what comments are. Comments, you just put the pound sign and space. And this is just, don't want to say it's just notes, but in a in good scripting fashion and cleanliness, you want to include comments as that is good documentation. Maybe you're working on something, you script it, and then 10 years later from then, you look back at your script and you try and figure out what was actually going on. Or if you work on a team, you want to leave comments so that other people can pick up and move the project forward, things like that. So all that this person is doing is we are commenting for good documentation. So what does this echo command do? It's asking the user to enter value. What's the read command do here? It's storing the user input value in a variable. You can read through these, but it's just explaining what each line is doing, and that is it's helpful for everybody. Now, you can extend the functionality of scripting. So if you're accustomed to getting tools and things off like GitHub or online, you might find a script where they'll have like entire variable sections that are commented out. And it's if you want to enable certain feature of the script, then you'll uncomment something out because then that variable is actually tied to, later down in the script. If enabled, then it will run through this whole subset of a script and provide this additional functionality. So base level comments are there to comment stuff. You can also store, commands. So if we put the number sign in front of this echo with a space in between, we commented out this this whole command right here. Then if we share it with people and say, hey, if you want it to do this and display, please enter your first name first, just uncomment that line. So you would go and you would delete the number sign and then it will run that command. So one thing that initially was made kind of for one purpose, and now generally you'll see it with a little bit more. All right. So we've talked about, oh boy, this is kind of a heavy task. All right. So we've talked about opening up Nano. All right. We talked about, let's see, the shebang portion, or was that the last one? Anyway, talked about variables, how to set them up, what they do, how to call upon them. We talked about loops, how to start them, how to stop them, what they look like. We talked about conditional statements as well. So if, then, else, then fi to close them out. And we talked about comments. All this is good foundational information to know. And if you can really nail this down, then you'll be able to build a good, castle to build up upon when it comes to scripting. All right. So let's go ahead and answer these questions. What is the shebang used in a bash script? So if you remember, every time we saw any coding examples, as well as when we put into our little script over here, it's going to be pound sign, exclamation point, then bin bash. All right. Next, what command gives executable permissions to a script? We went kind of into there. You know, it it wasn't, it didn't have its own area here, but it was a portion of it, and that's going to be that chmod command. So can you remember what the flag is on that, or the switch? Um, for executables is going to be an X, so we do plus X. All right. And finally, which scripting functionality helps us configure iterative tasks? All right. So when we're thinking of iterations, thinking of things being repetitive, repeating, that should be your loops. Okay. Bam. Alrighty. Next, we're going to move on to task 5, which is called the locker script. So in the previous task, we studied variables, loops, and conditional statements in shell scripting. Let's use that knowledge to create a shell script that utilizes all these components. So here's a requirement. A user has a locker in a bank. To secure the locker, we have a script in place that verifies the user before opening it. When executed, the script should ask the user for their name, their company name, and their PIN. If the user enters the following details, they should be allowed to enter, or else they should be denied access. So their username should be John, the company name should be TryHackMe, and the PIN should be 7385. All right, so we are looking through this script right here. So we got our shebang first, so it's define the interpreter, thank you comments. Then it's define the variables. We have 3 variables, username, company name, PIN, which coincide with what we are looking for. Then we're defining a loop. So for I and 1 through 3, do, so we're going to be doing these. We're defining the conditional statements. So if I is equal to 1, so the first iteration, then display enter your username. Then you'll give them read, and we're saying that variable is username. Else if for I, if it's 2, so if it's the second iteration here, then enter your company name. And the company name variable will then be asked for. Then else, then we're going with asking for their PIN. So we're setting usernames, we're saying company name, and we're saying the PIN, trying to see if it matches our value. So we're going to close that loop with done. Then we're going to have a conditional statement here where we're checking to see if the user entered the correct details, because now we have these variables established. So if username equals John, and so that's what 2 ampersands, I believe those are ampersand, 2 and signs, the company name is TryHackMe, and the PIN is 7385, then you'll display authentication successful. You can now access your locker, John. Else, so if one of these does not match, then say authentication denied. So they can do all 3 wrong, authentication denied. They could do 1 wrong, authentication denied. And that's what the double and signs are saying is, and this must be true essentially. So, and this, and that, and that, and that. All right. So then when they execute the script, so they execute the locker script, let's say enter your username, they put in John. Enter your company name, they did TryHackMe, they enter the PIN, and they said 1349, which is not 7385. So then it said authentication denied. All right. So what would be the correct PIN to authenticate in the locker script? It's not going to be 1349 because that one just did it wrong. It's going to be 7385. All right. And you can see that also right here where that's what it's checking up against. All right. So 7385. This task was primarily just to get accustomed to interpreting what you're actually seeing and understanding, okay, this is what's going on. I know this part we didn't exactly hit in the previous task where we're doing else if, but we did do if then else. So combining what we previously learned upon, building a little bit more with the foundation. Okay, so here's what it looks like if we're doing conditional statements that are also tied into, looping through and saying, okay, this. All right. So, not rocket science, but if it's new, it will take a while to understand why that's doing what it's supposed to do. There's other videos online. You can look more in depth about those certain commands and how they all work. Do your own research if you want to. Remember, this is at a base level. We're doing Security 101. We're trying to get your feet wet in a lot of different topics here. We're not diving in though. All right. Finally, we have a practical exercise. So we have placed script in the default user directory of the attached Ubuntu machine. This script searches for a specific keyword in all the files with the log extension in specific directory. So that's what we ran earlier, this flag_hunt script. All right. So note, some changes are required inside the script file before you execute it. When you open the machine according to the instructions task 2, you'll be able to gain the session as a normal user. So we are a normal user. However, we recommend that you become a root user in order to search for the flag in all the files of the given directory. So to become one, you need to type in the following command, which is sudo sup. So sudo super user. All right, now I'll ask for the password for the user, And remember over in task 2, it gave us credentials. So we are going to do this password, which is, for me, user at TryHackMe. See, did that work? Nope, I did a typo. There we go. So I can see that that worked because I'm no longer user at TryHackMe. I'm now root at TryHackMe. All right, so cool. Um, so let's go back to task 6. So you can make the changes in the script file by keeping in view the following details. So the flag name is this thm flag01 script, and the directory is /var/log. All right. Then we have a hint, look for empty double quotes inside the script file and fill them and make sure not to leave any space between them. So first thing we're gonna do, this is directory contents, cool, we're still there. We wanna edit this, so we're gonna open up with nano. So we're gonna do nano space FL, then I tabbed on over. All right, so nano has now opened up. To navigate in nano, you're not clicking around with your mouse, you are using the arrow keys. So if we look, let's go ahead and take a moment to analyze what the script is actually doing. We have our shebang, we're doing it in bash. We have comment here to find the directory to search for our flag. So directory equals double quotes, and the hint said, look for the double quotes. So we're probably going to need to put the directory value in there. So it's not asking for a variable that we're directly setting that. All right. Next, we're defining the flag search. We have that information as well, so we can plug that into that area right there. Then, so we set our directory, we set the flag to search for it. It's going to echo and display flag search in directory. Then it's going to call that directory. So it should say the directory of var/log, once you plug that in, is in progress. Now it's defined for a loop to iterate over all the files of the .log extension in the defined directory. So for file in uh, double quotes, so we're probably gonna have to define that directory again. We can either put in var/log, or we can plug in the variable that we've established for that as well and just call the value in from variable. Um, then it's looking for /wildcard.log, so anything that is with the log extension, semicolon do. Now it's checking if the file contents still contain the flag, which it's using through grep, so grep. I always say that wrong, but it's grep. All right. Don't be like me. Don't say stuff incorrectly. All right. It's not incorrect. It's still reading it, but it's like people that won't say SQL when they see SQL, and they'll say SQL, and it's just say SQL. All right, please. But anyway, that's a little side tangent. All right, so grep tat-q, then we're calling upon the flag variable as well as the file variable. All right, let me poke around my mouse so you guys see what I'm talking about. The flag variable here and the file variable. Then we'll print the file name, so it's going to echo because it needs to display something. Where flag found in, it's going to give a base name and file, and then we close the loop off with fi, say done and everything. Okay, so we need to define a couple things here. Well, 3 things. All right, so let's go ahead and start plugging that in. So our directory, we know what directory that they asked for because they told us, which is /var/log, not log. And if you remember the hint, it says make sure not leaving spaces in between them because typically that space will just be there. So clean up, it should look like this. All right, so it should have a space before or after it, otherwise it won't run properly. Next, in the flag, we are going to put thm tac flag01 tac script. Then we're going to go down to this area for the file. So we can put /var/log. I want to see if this runs right by putting in /var/log. Instead for that, we're calling upon the variable of directory. And that means in the future, I can use this script where I'm not going to have to change 2 locations if I change the directory. I just have to change it in 1. And seeing how we did the other portions of this whole room, you can ask somebody to input the variables with the read. So they could start the script off with echo, which directory do you want to search for? Then have read directory. And then when we put in the directory, we're now setting that variable like that. And the same thing for then having an echo statement saying, well, which flag do you want to search for? Read flag. All right, so there's ways to build upon everything. That's using what we've learned so far in this room to try to make it more efficient for future iterations of it. All right, so now that we have defined where we're looking for and what we're looking for, and we made sure that there's no spaces, we want to save this and exit out. So looking at the bottom here, I'm pretty sure my head's gonna cover up some of these, but you can get help. You can write out exit, read file. To do those, it is the control key as well as whatever letter it's asking for. So we want to exit. So we're gonna hit Control X, and now at the bottom it says save modified buffer because we've changed the contents of the file. We're going to hit Y for yes, and then it will ask us the file name to write. So you could rename this to Flag Hunt Updated or Flag Hunt 2 or whatever. We're going to leave it as its name, and that's going to overwrite what it was. All right, so now we want to run this. We already know that run, so we don't need to make it executable with chmod plus X. We just need to call upon it. We are in the directory. Do you remember how to do that? To do that, it is the period forward slash and then the name of it. What I'm going to do is because I already ran this earlier, I'm going to use history and go up, 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 and then realize, oh no, the history that we used was for the other user. It was under our normal user. Remember, we switched over to root. So history doesn't do the entire session that you're in a terminal or whatever. If you switch users, it's considering that a brand new instance. All right. So let's go ahead and do period forward slash. This is called flag hunt. So we'll do F, we'll hit tab, we'll go ahead and run it. And now we have flag search in directory slash var slash log is in progress. Flag found in authentication.log. So we now know where we want to be looking. So we have two questions here. Which file has the keyword? And we just found that out, which is authentication.log. And now we have where's the cat sleeping? So we probably need to find, or we probably need to open up that log and take a look at it. So right now we're in the home user directory. We know we want to change and go into the var slash log directory. And this is why we went to root and not the normal user, most likely. So I'm going to do cd space var slash log. Whenever I'm moving around directories out of habit, I will do list ls to see what is in there. And as we can see, we do have an authentication.log here. We have a whole bunch of other stuff too, but this is the one that we're interested in. And to read that out, I can do cat authentication.log, or you could even do, oh wait, did I spell that wrong? I did spell that wrong. And that's why it's good to use tab. All right. Remember, no spell check for anything in bash. All right. And it says the cat is sleeping under the table. So cool. We now know where the cat's sleeping. That's under the table. You could open it up with Nano as well, I'm pretty sure, if you wanted to see what that was about. But like, if you're just reading it and if you don't have a purpose to modify it, typically cat works absolutely fine. Because, yeah, boom, I did spell that wrong again. Alrighty. So don't be like me and spell stuff wrong. All right. Authentication.log. There we go. And it will list up here the cat sleeping under the table because that's the contents of it. So this log essentially is like a text file, and it will just say, boom, there you go. And the second line of it says THM flag01 script. So cool. If you followed along, you've made it through this practical exercise, which leads to the conclusion. So in this room, we studied the importance of shells. We flew to the world of Linux shells. We explored their major types. We gained a good understanding of shell scripting and its role in automating tasks. And then we created some cool shell scripts and solved a practical lab pertaining to a script that finds mysterious things out of different directories. All right. That was a good example script because that's a function that you can kind of use for multiple things. finding contents of files and being able to filter by, hey, we're looking for an exe, maybe we're looking for this. It's just improving on grep a little bit. But that was cool. I hope you guys had fun. I hope you guys learned something new. Hopefully this video helped you out, but regardless, congratulations on completing the Linux shells room. I believe next we're hopping into some networking stuff, but we'll cover that in the next video. So thank you all for watching. Good luck.